everyone, and welcome back to Global Education Zone. And in this particular video, I'm doing a revision on the previous episode we've been doing. I'll be doing a revision on those previous episodes, and also we'll be touching some different methods you can use in mathematics. So let's talk about those. I'll be doing these in 3 examples. So pay attention and take something from this video. So the first thing we'll be using the graphical method to solve for simultaneous equations. So in your earlier mathematics courses, you should have understood that if you attend school, by now you should have known before coming to this level that there are 3 methods of solving simultaneous equations. There's the elimination method, there's the substitution method, and there's the graphical method. Now the first 2 methods, they make use of the algebraic processes, which I've been talking about in these videos, and which, assuming that you've been going to school, you should be familiar with those. Then the graphical method is one which is not very familiar, but it's also very versatile and useful, and gives us a first-hand information of not just the solution but also how the curves look. So I'll be making use of a sketch today, and I will be solving 2 equations at the same time. So now the first equation will be y is equal to x minus 7, and the second is y is equal to 1 minus 3x. So now, if you can plot the tables of values with me, let's do that together. Now, then the first one is y is equal to x minus 7. When x is minus 1, y will be minus 1 minus 7. So I don't even need a calculator for that. That will be minus 8. When x is 0, just substitute your value of x at each of the points. When x is 0, y is 0 minus 7, that's minus 7. When x is 5, y is 5 minus 7, that's minus 2. Simple. And anytime you have an algebraic expression or equation where the highest power of the unknown is 1, that would be a straight line graph. But when the highest power of the unknown is 2, that would be a quadratic graph or a parabolic graph. Where it is 3, you get a cubic parabola, and so on and so forth. So these are things you should know if you want to further your studies into an engineering or science field. Now next we have the second graph, which is y is equal to 1 minus 3x. So when x is minus 1, y is equal to 1 minus 3 times minus 1. That's 1 minus 3 times minus 1 is plus 4. That's y is 1 plus 4. That's 1. Y is 1 plus 3. That's 4. When x is 0, y is 1 minus 3x, that's 1 minus 0, that will be 1. Because anything that multiplies 0 gives 0. Then we have when x is 5, y is 1 minus 3 times 5, that's 1 minus 15, that's minus 14. So far so good. Let's get to the axis. So I will just sketch the axis here. Now imagine we have an axis. These are the axes here. This will be the negative x-axis, this will be the positive x-axis to the right. Above we have the positive y-axis, and below we have the negative y-axis. So this is just a sketch, but it should at least give you at least 50% information of how the graph is plotted. Now let's use the values of x. For both, we can see that our values of x are minus 1, 0, and 5. So let this be 1 unit. This will be 1, minus 1, minus 2, minus 3, minus 4, minus 5. I'm trying to make it as equal as possible. 1, 2, 3, 4, 5. These are positive values, negative values. Then in this y, so we are going to adjust the values based on the scale and based on the magnitude, the order of magnitude of the y coordinates. So because y coordinates, what's the maximum? The maximums here are, so far I can say that the maximum is 4 in the upper, then the minimum is minus 14. So that's how you plot graph. You make use of the maximum and the minimum. So when the minimum is when it goes very well below the origin, which is this is the origin, this intersection point is the origin. When it goes well below the origin, that means you have to extend your line longer. Let's extend this line longer. So you have to be able to estimate your regions before you plot your graph. So we can use a scale of 1 of 1 box means 5 units. So 1 box of 5 units. So depends on where you are plotting and how big your graph is supposed to be. So if you have a graph, you should be able to look at the those boxes, and then one of those boxes you should be able to accord the units based on the order of magnitude and how let's just say the range of your y values and your x values. So since this goes down to minus 14, let's give each of these a value of 2. So we can say this will be 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14, minus 16, minus 18. So that would be the maximum. Then this will be positive plus 2, plus 4, plus 6, plus 8, plus 10. So in order to make everything too difficult to see, I won't write any values here. So I'll just plot. So when x is minus 1, this is minus 1. Y is corresponding value of y is minus 8. So minus 1 on the x-axis and minus 8. 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. So where they intersect, that would be one point of the curve. Then we have when x is 0, y is minus 7. So 0 and minus 7. It's right here. 1, 2, 3, 4, 5, 6, 7. When x is 5, that's this 5 here. Y will be minus 2. That's minus 2 here. That would be. So you can see that this represents a straight line graph. If I were to draw a straight line through this would pass through each of the points. It used to be a straight line graph. Then, so moving on to the second graph now, we still have values of minus 1, 0, and 5. So when x is minus 1, y is 4. This is a positive value, so circle it here. When x is 0, y is 1. That will be a value here. Then when x is 5, y is minus 14. That's minus 2, minus 4. Okay, I think I made a mistake somewhere. So let me correct that. With the scale of the graph, we are supposed to use 2 units, but I used 1. Let me correct that. So I haven't corrected my errors. I've been able to sketch the graphs. So basically what that means is when you've gotten your points, you just connect the points using a straight object or an object with a straight edge like a ruler. So you get something like this. And then the solution of these two equations, which are also known as simultaneous equations, the solution lies in the point of intersection of these two. So where this one intersects this one, where they cross, that point is the solution. So if you read this off, if peradventure you've been plotting on a standard graph, you will get this as the x value of this is 2 and the y value is minus 5. So at these 2 points, at this coordinates, very coordinate, that is where these graphs are simultaneous and they are satisfied. So that is how to solve simultaneous equation using graphical method. So let's move on to the next question for this revision process. So the next question here we'll be dealing with, we've done logical reasoning in some previous episodes of this mathematics for senior secondary school 1. So today I will give you an example on that. So given the statement P such that X is a politician. So if this is statement P, if statement P is X is a politician, and then statement Q is X is over 25 years old. Statement Q is X is over 25 years old. Now the question says, the first part of the question says, express not P in words. So express the negation of P, that's what it means. So this first part says we should express this of P, that's negation P. And that will be what? That is the opposite of P. Negation of a statement is the opposite. So if P is X, if P is implies that X is a politician, then not P will be that X is not a politician. That would be the negation. And the second part of the question says, express not Q in words without using the word not. So now they're asking us to express word not Q in words without using the word not. So let's try that. B. So not Q on the negation of Q such that. So if Q means X is over 25 years old, so the negation of Q was supposed to be X is not over 25 years old, but now we are restricted. We are not to use the word not. So let's use another word. So if X is not over 25 years old, that means what? If X is not over 25 years old, try to understand the question. So is not X, if X is a person and the person is not greater than 25 years old, that means it's possible that the person could be older than 25 years, but the person will not be greater than 25. And it's also possible that the person would be 25 years. So if the person 25 is not greater than 25. So those two conditions satisfy the this proposition. So we can say x is lesser than or equal to 25 years. X is lesser than or equal to 25 years. That is one expression, that is one example by which you can express the negation of statements in different forms, even without using the common connective not. So moving on to the next part of this question. So the next part says we should express P implies Q in words, and then we'll also express the next part says we express P is equivalent to Q in words. So you should have known from the former episodes I did on logical reasoning that whenever you have an implication, it's read as if P then Q. That is the meaning of an implication. So this sign, this forward arrow, is an implication symbol, and it's the connective that is used to represent the fact that if the first is satisfied if the second is satisfied. So that is right. If the first implies the second. So since we have the letters here, we'll say if P then Q. So if P is X is a politician and Q is X is over 25 years old, we can represent it as if X is a politician, then X is over 25 years old. So you use the words if and then. Whereas in biconditional statements, it's just a combination of two implication statements. So basically, the one of them is going forward and one of them is going backward. So you have P implies Q and Q implies P. So if you read it forward, P implies Q. Then if you read it backward, Q implies P. So if you combine them together, that would be P implies Q and Q implies P. So P implies Q is X. If X is a politician, X is over 25 years old, right? That means Q implies P what? If X is over 25 years old, then X is a politician. So when you combine both of those by the connective and, you get a biconditional or equivalence logical proposition. So that is how it's done. So that would be if X is a politician, then X is over 25 years old, and if X is over 25 years old, then X is a politician, because it goes both ways. Look at the arrows, they go both ways. So that is all for this question. So moving on to the last part of this video, we're talking about factorization. So let's try factorizing quadratic expressions. So let's try by using the method of factorization. Now, as you can see in this last part of this video, we are going to be factorizing an algebraic expression, and this is also known as a cubic expression. Why? Because the highest power of the unknown or variable is 3. So this 3d raised power 3. So this power, this exponent, this index determines the order of the equation. Now, we are supposed to factorize, right? So what is common out of everything first? So you can see that this is 3d cubed, this is minus 39d squared, this is plus 90d. So you can see that all of them have d. So let's factorize d out first. So when factorize d out, that will remain 3d. When factorize 3d, when factorize d out of 3d cubed, that will remain 3d squared minus. When factorize d out of 39d squared, that will remain minus 39d. And then when factorize d from 90d, that will remain 90. So we have in essence changed this into a quadratic equation from a cubic equation. So what else is common? So we can see that 3 is common here because 3d squared is divisible by 3, minus 39d is also divisible by 3, and plus 90 is also divisible by 3. So let's factorize 3 out. So when we bring 3 outside, that will be 3d outside the brackets. So inside the brackets we have d squared minus 39 divided by 3, that's minus 13d, plus 90 divided by 3, that's plus 30. Then using the method I recommended earlier, which involves you looking for two factors that whose product will give the product of the first and last term, and whose addition or sum will give the middle term. So if you try that by trial and error, you get 3d. So when we use those, when we replace the middle term by those two new factors, that will be d squared. The new factors for this one will be minus 15 and minus 15d and plus 2d, because when you multiply them to give us the minus 15 and plus 2d. So let's see about that. Okay, yes. Our answer is positive, yeah. Let me try. So I've successfully looked for the factors, and that is minus 10d and minus 3d. Then we write the last step plus 30. Then when we factorize, we have 3d. We factorize the first two, we have factorize d out. D open bracket d minus 10 close the bracket. Then when we factorize minus 3 in the second two terms, we'll have minus 3 d open bracket, we'll have minus 3 open bracket d minus 10. So when we factorize d minus 10 again, we have 3d open bracket d minus 10. Then we'll have close bracket, then we'll have open bracket again. The first one, d minus 3. So you can see that after this factorization, we have 3d times open bracket d minus 10 close bracket times open bracket d minus 3. So that is the complete factorization of this question. And if you are asked to solve for it, you'll be equating this to 0. And then when you equate an algebraic expression, it turns into an algebraic equation. So that's where you make use of the factorization, and then assuming that whenever you multiply anything that equals 0, that means at least 1 must be 0. So that means you say if this is equal to 0, that means 3d is equal to 0, or d minus 10 is equal to 0, or d minus 3 is equal to 0. So you solve that equation. So this is basically going to be a revision of what we've covered so far, and see you in the next episodes.